Okay, so number one, the first one at the top of your paper. When you read a question, every variable, every like number with a unit after it, right? You have to decide, is it a pressure, a volume, a temperature, or moles? So it says a 16.1 liter sample. So liters tells us that this is a volume. So that's a volume of gas at 23 degrees Celsius. Celsius is a temperature. Is heated to 76 degrees Celsius. That's also a temperature. That's the paper I gave you. It says, what is the new volume of the same gas sample when kept at constant pressure? So, I have a volume, I have two temperatures, and I'm asked to find another volume. So which one of these can I use to do that? The last one, okay? I have two temperatures, and this is the only one that has temperature twice, right? So we're going to use the last one. P1, V1 over N1, T1 equals P2, V2 over N2, T2. Now, that's a lot of stuff, and I don't have that many numbers, right? So anytime you use this equation, you get rid of stuff you don't need. So it says pressure is constant. That means it doesn't change. That means we don't need it. So we're going to get rid of pressure. What else is not mentioned in this problem? N, moles. So if we don't need it, we get rid of it. So really, we're going to use V1 divided by T1 equals V2 divided by T2. So now we have to figure out, well, what are the ones? That's what we start with. And what are the twos? That's what we end with. So it says a 16.1 liter sample of gas at 23 degrees Celsius. So these are both my ones. Is heated to this temperature. So it changed to that. That's my second temperature, right? And now I can plug what I know in. So V1 is 16.1 liters divided by T1, which is 23 degrees Celsius. But if you go back and read what you just wrote on the last slide, it says temperature must be in Kelvin. So anytime you plug a number in for T, it has to be in Kelvin. So we change Celsius to Kelvin by adding 273. So that's 296. That's the number we actually use in our calculation. So that's equal to V2. That's what we're trying to find. So that's like our X. Over T2. So I also have to change this by adding 273. 388. So we plug that in. So now it's a lot like math class where you can cross multiply.
Where did you get the 273?
This?
Yeah.
So that's just like from your notes from Tuesday, changing between Celsius and Kelvin. So anytime I have two fractions, I can cross multiply, right? So I multiply these two numbers. I multiply these two things. 296 equals a lot.
5,668.
Point.
90.
Thank you. Times V2. Right. That's what I'm solving for. It's like X. So now I divide both sides by what? 296. V2 equals 18.9. My units for volume are always L. No, not at all. So when you cross multiply, you don't have to do all of this work, right? If you know, when you cross multiply, you multiply the two numbers that are diagonal from each other, and then divide by the number that's diagonal from the thing you don't know, right? So wherever the thing I don't know is, the thing up is what I divide by, right? If you know that, you can save yourself some writing. Otherwise, just show all your work. Questions?
Okay, we'll go to the next one.
Yes. Number 2. So it says, what is the total pressure in a closed container of a gas mixture containing 320 millimeters of mercury of hydrogen? So these units measure what? Volume, temperature, pressure. So this is a pressure. 200 millimeters of mercury of nitrogen is also a pressure. And 100 millimeters of mercury of oxygen is a pressure. So we're asked for pressure. We have nothing but pressure. So we use number 1. P total. Does it matter which one is 1, 2, and 3?
Yeah.
Not really, because you're just adding them all together. So I add them all together. The last thing you need are units, mmHg. That'll right on your paper. Right. This is the second one. So somebody earlier asked a good question, what if all of these were not the same units? And so you can only plug them into this equation if they were all the same. So if this was like mmHg, but this one was atmospheres, then you would need to change it so that it was the same as the others. Okay? I don't think there's any like that you'll come across, but if you did. On the test, it would be all the same.
What about number 2?
What? Yeah, we're going to get there. All right, the third one. When the temperature of a cylinder with 685 liters is a volume of helium gas is held at 621 Kelvin. Kelvin is a temperature. The pressure is 1,890 kilopascals. This is a pressure. How many moles? Moles is what letter? N. Trying to find N. Of gas does the cylinder contain? So I have 1V, 1P, 1T. I want N. So I'm going to use number 2. Okay? I only use number 3 when there's 2 of the same letter. I don't have any 1 twice, so I'm going to use number 2. PV equals nRT. Because of what it's given. So like in the last one, you were giving nothing but pressures. So you have to use pressure. In the first one, you were given 2 temperatures. So the bottom one's the only one with 2 T's. And in this one, you're given one of everything. So use one in the middle. So I plug in what I know and solve for the one thing I don't. So P is pressure. Pressure is 1,890 kPa. Times V, volume is 685 liters, equals N. Do we know N? No, so we leave it as an N. R. You will never be given R in the problem. For R, there are always 3 choices. And if you look at the 3 choices, the number is different each time, but they all have liters, they all have moles, and they all have Kelvin. The thing that's different is the pressure. So you have to look at your pressure. Your pressure is in kPa, so we're going to pick the one that has kPa and use that number. And then T, temperature still has to be in Kelvin. Luckily it already is, so you can just plug 621 right in. So I can multiply the left side. Yes, big number. And then I multiply the right side. And how am I going to get N by itself? Divide by which number? And the units for N are always, what does N stand for? Mole.
What number is this?
Okay, so we just did one example of each type of equation. We're going to do the next 3, which is one more of each type, but they're like the things that often go wrong, right? So like the worst case scenario of each one. This way then you should be So, just like always, 1.75 liters. Liters is a volume of a gas in a flexible container at 1.30 atmospheres is a pressure. If the pressure in the container is reduced to 0.950 atmosphere, also pressure, what is the mu volume if the temperature is left unchanged? So, we have 1 volume, 2 pressures. We know we need to use number 3 because there's 2 pressures. So we have P1 V1 over N1 T1 P2, V2. So, what can I get rid of? Temperature is left unchanged. I get rid of temperature. What else is not mentioned? N, I get rid of that. So now I don't have any fractions like the first time. So you won't cross multiply this time. And divide. Yeah. So I just use the top part. P1, V1 equals P2, V2. So this is my starting volume. This is my starting pressure. It is reduced to, so that means it changes to this pressure. And mu volume means I'm trying to find the second volume. So I could plug everything in. P1 is 1.30 atmospheres. V1 is 1.75 liters. Pressure 2. So this time is the only way you won't cross multiply, right? Most of the times you will. When you have two fractions, you cross multiply. That's the easiest way to solve for that. Here you don't, because there's no fraction. So you multiply these two and divide by 0.950. And so you get V2 is equal to, remember, 2.39. And volume is always what units? Liters. Don't forget to put units. You would lose points for not putting units. Not all the points, but some points. Alright, this is like the most missed problem, believe it or not. So it says what pressure, oh no, not this one, the next one. What pressure in kPa will be exerted by 0.45 moles, so moles is letter N, of a gas at 25 degrees Celsius. Celsius is a temperature contained in a 0.65 liters is a volume. We're looking for pressure, right? So, one of each I use. Number 2. So, we don't know pressure. We can plug in our volume. N R. Now, remember R you picked from the list. R is always based on the pressure, but we don't know the pressure. So you have to go back and look at the question. What pressure in kPa? So be careful with that, right? So it always has to match the pressure. If your pressure is what you're looking for, it will tell you in the question which one to use, okay? So in this case, it's the same one. It won't always be the same one. And then temperature, remember temperature must be in Kelvin. So we change to Kelvin by adding. Add. 290. So this one, we just divide. We'll save some time. I won't make the calculate. So my units for pressure are kPa. Right. Has to match my question.
Does this say 1714?
Oh, like you could, you should. I got lazy. You could, you should. I did. The third time. Okay, last one. Yeah.
There's two
But
more.
this is the last one I'm doing.
Oh.
So, you have to read very carefully when you read these questions, okay? Because this looks a lot easier than it is. It's not hard. It just looks easier than it is. A mixture of carbon dioxide, oxygen, and nitrogen has a total pressure of 0.6 atmospheres. So that's a pressure. If the pressure of O2 is 0.1 atmospheres, also a pressure, and N2 is 0.3 atmospheres, also a pressure, what is the pressure of CO2? Okay. So, all pressures knows we need to use number 1. Yes, here's the back. Sure. So, you do not always just add all of them together. Okay? If it asks you to find the total, yes, you just add them all together. But this one tells you the total pressure is this much. So this isn't 1, 2, or 3. This is the total. So we're going to put that first. Which means this is 1, this is 2, and we're really looking for number 3. So we have 0.1 plus 0.3 plus the one we don't know. So we don't just add them all together. How can I solve for the one I don't know? So add these two first. And then I can subtract. You do the last one. When you get it right, I give you your assignment. You never do it, or you never do it right, you'll never get your assignment. What? I said you do the last one.